So this is regarded as infinite ladder network. So whenever I solve this problem, I teach a small concept to students. You can consider it this way, that if you are solving a problem like x is equal to 2 upon 2 plus 2 upon 2 plus 2 upon till infinity. So whenever we solve this kind of a problem, we replace this segment and then we treat it as x. Why? Because removing these two is not going to affect the quantity which is going till infinity. So we write it as x is equal to 2 upon 2 plus x. So from here we can say that if the effective resistance R effective be the effective resistance, then I can redraw this circuit in this way, that this is equal to R, this is another R, this is another R, and this entire network is replaced with R effective. So this is R effective and all these values are equal to R, and the value over here will again be R effective. So if I solve this network now, so I can say that these two segments are in parallel. So R parallel is equal to R1 R2 upon R1 plus R2, and then the parallel value of this and these two are in series with each other. So we say it as 2R RRE upon R plus RE, and the effective value is equal to RE. So I can rewrite this as 2R plus RRE upon R plus RE. Now over here we have the value of R as equal to 1. So if I put the value of 1 over here, we can solve this out and obtain it as RE is equal to 2 plus RE upon RE plus 1. And the equation is going to be formed like this, that RE square minus 2R minus 2 equal to 0. So if we solve for R, which is equal to minus B plus minus root over B square minus 4AC, that is 4 minus 2AC by 2A. So we get R as 1 plus root 3 ohm. So for this particular problem, 1 plus root 3 is the correct alternative. The negative answer is not possible, that is why we cannot put it as 1 minus root 3. So the value of effective resistance is going to be 1 plus root 3.